It's time for the Chapter 7 tests. So let's review. We'll start on page 481, which is the practice test in our textbook for Chapter 7. For number 1 and number 2, they just ask us to simplify the expression. So I'll be writing for most of these, but these already got written down. So anyway, we have x to the second, or x squared, times 7x to the 8th. So the coefficients we can combine first. There's just the understood 1 in front of x squared, then the 7. So we just have a 7 as far as the coefficient. Then we have x squared times x to the 8th. Those are two bases, and they both have exponents. And when you multiply two bases with exponents together, you add the exponents. So you do 2 plus 8 and get x to the 10th. Okay, now here's the question for number 2. It's a little bit more, but it's still the same process. We start by multiplying the coefficients together. 5 times negative 6 is negative 30. A to the 7th times a squared. We add 7 plus 2 and get a to the 9th. Then I wrote the 1s here. They just wrote b, but it's understood to be b to the first power. So b to the first times b to the first, we add 1 plus 1 and get b squared. Then we have c squared times c to the 5th, so we add 2 plus 5, get c to the 7th. Okay, number 3. I'm going to quickly draw a cube for us. They ask us to express the volume of this solid as a monomial. So they show an x here, an x here, and an x here. So whether you call it length, width, and depth, or height, base, and depth, whatever, these are our 3 dimensions. And so we would multiply x times x times x. So x times x times x, that's x to the first 3 times. So we add 1 plus 1 plus 1, and we get x cubed. So the correct answer is A in the textbook. Number 4, we're told to simplify, and we're told to assume that no denominator is equal to 0. That won't really change anything. So remember, like up here, when we were multiplying, we added the exponents. When we're dividing, we subtract the exponents. So I have an x on top and an x on the bottom. 6 minus 2 is 4, so that becomes x to the 4th. And this is the only place y shows up, so it doesn't change, it just stays y to the 8th. So we end up with no denominator because essentially that x squared got canceled out and took 2 away from that, making it x to the 4th. Number 5. 2a to the 4th b cubed divided by c to the 6th, all raised to the 0 power. So this one looks like a kind of monstrous problem, but then you need to remember a really important thing. Anything raised to the 0 power equals 1. So there's really very little work to do on this one except to remember any number, any exponent, any combination of numbers and exponents raised to the 0 power equals 1. Okay, number 6. 2x y to the negative 7th over 8x. So we see the coefficients are 2 and 8. They're both divisible by 2. So we can reduce those. 2 divided by 2 is 1. You don't have to write the 1. 8 divided by 2 is 4. You do have to write the 4. Then we have x divided by x, which is 1. So it just cancels out because anything divided by itself is equal to 1. Now we don't want to end with negative exponents. And as you hopefully recall, negative exponents can be made positive if we change what part of the fraction they're in. So while this is a negative exponent when it's in the numerator, the top, If we move it to the denominator, it becomes a positive exponent. Okay, for 7, 8, 9, and 10, these are things we can do in the calculator. Yeah, the cube root of 1,000. I'm just going to write them all first, then I'll pull up my calculator. And we'll do them from there. Okay. So let me get my calculator. I think I can also make it so you can see the version you guys will have. Yes. So just as far as pointing out the buttons, this is just an image. This is not something I can work on, but I'll refer to it when I need to. So the first thing we have is the cube root of 1,000. Now on your calculator, the way that you will do the cube root is using this button above the caret. Remember, this caret can give you any exponent you want. This button up here allows you different roots. That's the square root right above x squared. This lets you do any root. So on your calculator, you would type in 3, then hit second, then the caret button, and type in 1,000. So my calculator on here actually has a cube root button, so I can do the cube root. Let me try again. Okay, so I can do the cube root of 1,000. That's the square root. My fault. Cube root of 1,000, and we get 10. So again, you should get the same thing on your calculator when you hit 3, then second root 1,000. And I'm afraid since I have it in front of me, it's possible you hit second root then the 3, but just experiment and figure out if you do the 3 first or the root first. But I know you have to hit both of those to make that work. Okay, number 8. This is the fifth root of 3125. So you will do 5 second root of 3125. Okay, on my calculator on here, I'll do the fifth root of 3125. So my button looks like yours. I have to do things in a little different order, but 3125 is the fifth root of 3125. So hit enter, and you get the number 5. Okay, next we have 1728 to the 1/3 power. So that can also be done in the calculator. So on your calculator, you'll type in 1728, then hit this button right here, the caret button, and since it's a fraction, you'll need to put it in parentheses. So raise to the parentheses 1 divided by 3. So it's 1728 raised to the 1/3, 1 divided by 3. And it is 12. Okay, last one, 16 over 81 raised to the 1/2 power. So we'll need to use parentheses here as well. You need to do parentheses 16 divided by 81, parentheses, close the parentheses, use the caret button, raise to, so 16 divided by 81 in parentheses, raised to the parentheses 1/2. Or you can also raise it to the 0.5. It's okay to convert it to a decimal if you want. So we have 16 over 81 raised to the 1 divided by 2. And that's 0.44, 0.4 repeating. So you could just write 0.4 repeating, that'd be fine. Another way you could do this one is if you remember, raising something to the 1/2 is the same thing as taking the square root of it. So you could say the square root of 16 is 4, the square root of 81 is 9. So that can be your answer, or that can be your answer. They're both equal. If you type 4 divided by 9 in your calculator, you'll see it's 0.4 repeating. So there's really two ways you could approach that one. Okay, now let's jump over to number 15, where we are to solve each equation. So 12 raised to the x power is equal to 1728. Now remember, we're wanting to figure out how we can get the same base on both sides, because if the bases are equal, then the exponents are equal. So it's fine to guess and check. Now, we're pretty sure 12 is going to be the base, but we don't know 12 to what power will give us 1728. So just guess and check. So like 12 raised to the third. Oh, I got lucky. Very first time. So 12 raised to the x power equals 12 to the third power. And if the bases are equal, the exponents also have to be equal. So that means x equals 3. We have 7 raised to the x minus 1 equals 2401. So again, we want to figure out, okay, what power of 7 will give us 2401. So we can do some guessing and checking. 7 raised to the 4th power. I'm really not getting it right on purpose every time, but hey, lucky me. But it's fine if you don't get it right the first time. If your result's too small, try a bigger exponent. If your result is too big, try a smaller exponent. So since the bases are now equal, 7 and 7, the exponents also have to be equal. So we can set x minus 1 equal to 4, add 1 to both sides, and get x equals 5. (17) is a similar problem. We have 9 raised to the x minus 3 is equal to 729. So hopefully you know it's not 9 squared. You should know 9 squared by heart. It's 81. So let's try 9 cubed. And there it is right away. So we've converted 729 to something that's equal to it, 9 cubed. Because now that the bases of these are the same, the exponents are also the same. So we add 3 to both sides, and we get x equals 6. Okay, 18, we are asked to simplify these radicals. So remember, what you got to do is think of the factors of this number and then see which of these factors has or is a perfect square. So like I know 98 is even, so I can say 2 times 49. And that's probably our winner right there, because that's a big number, relatively speaking, as far as factors. It's a perfect square. But just in case, we'll keep going. 3 does not go into 98. And remember, you can test that in your calculator. You could do 98 divided by 3. If it's a whole number, there's your two factors. If not, then keep going. It doesn't go into 4. Not 5. Not 6. Not 7. Not 8. No, actually 7 does. Here, let me use my calculator to help me out. 98. Whoop, that's not 98. 98 divided by 7. It's 14. So 7 times 14. And I'm pretty sure if you keep going, you find these are the only factors of 98. So, as we look, the only perfect square is the 49. So we can change this to the square root of 49 times 2. And we're also allowed to split that into two different square roots. The square root of 49 is 7. And we can't take the square root of 2 evenly. It doesn't come out to a whole number, so we just leave it. And we get that the square root of 98 is equivalent to 7 times the square root of 2. Okay, 19 is similar, only this time we have two square roots. Square root of 6 times square root of 18. And before we try to figure out factors, we should go ahead and multiply these two together. So 6 times 18, I think that's 108. I'll double check that right now. 6 times 18 Yeah, 108. So we know that's even. So 2 times 54. And also 3 works. Let's see, 108 divided by 3 is 36. Hey, there's a perfect square, so this could be our 1. 4 works. It'd be 4 times 27. 5 doesn't work. 6 does. Let's see, 108 divided by 6. Whoops. Is 18. Don't think 7 or 8 works, but we'll try it out. 108 divided by 7. Okay, that's not a whole number, so that's no good. 108 divided by 8. Nope. 108 divided by 9. Ah, there we go, 12. So 9 and 12. There's another perfect square. I know 10 won't work. 108 divided by 11 doesn't work. And no need to check 12. We already know 12 works. So we do have 2 perfect squares in this. Oh, actually 3 perfect squares in this list. When you have more than one, always choose the larger one. So we're going to choose 3 times 36. Split this into 36 times 3. Square root of 36 times square root of 3. The square root of 36 is 6. This is not a perfect square, so we will leave it inside the radical. Now 20 adds in some variables. Now on this, what I encourage you to do is focus on the number and the variables as 2 separate things. It's easier to kind of break this into 2 pieces. So first, let's focus on the number, 50. So 2 times 25, there's a perfect square. 3 is a no, 4 is a no, 5 times 10, and that's all. So we'll use this one, the 25. So just focus on the 50 for the moment. We'll do 25 times 2, square root of 25 times the square root of 2. So the square root of 25 is 5, and the square root of 2 we'll have to leave inside. And I left some space here so we could fit the variables in. So when you're taking the square root of a variable, you say, okay, how many times will 2, because there's an understood 2 here for square root. Square root is the opposite of squared, so it's the second root. How many times does 2 go into 3? Goes in 1 time, so 1x comes out, but 1's left over, so we have to leave 1x inside. So how many times does 2 go into 3? 1 time, so we can pull 1x out, with a remainder of 1, so we leave 1x in. Then we do the same thing for the y. How many times will 2 go into 2? Well, that'll go in 1 time, so I pull 1y out. There's no remainder, so no y remains inside. (21) square root of 10 over 25. So what I would do first on this one, anytime you have a fraction, is see if you can reduce it, and we can. Those are both divisible by 2, so I can, by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And we can split this up into 2 different radicals. But remember, things are not simplified when they have a radical in the denominator. So our solution to that is to rationalize the denominator. Rationalize the fraction, which means we multiply the top and the bottom by the denominator, or at least the square root in the denominator. So the square root of 2 times the square root of 5 is the square root of 10. And the square root of 5 times the square root of 5 is 5. Okay, give me a moment. I got to turn the page. We have just 2 more. They're on page 425, number 55 and 58. Ah, yes, okay. Okay, number 55, we're distributing because it's got the square root of 5 times the square root of 2 plus 4 square root of 2. So we distribute just like normal. Square root of 5 times square root of 2 is the square root of 10. And then remember, when you're multiplying, things outside the radicals can combine and things inside the radicals combine. But not something inside, like the 5, and something outside like the 4 don't combine. So 4 is the only thing outside, so it just stays outside. Square root of 5 times square root of 2 is square root of 10. Now if you notice, these two are like terms because they both have the square root of 10. This is 1 square root of 10, and you add 4 more square root of 10s, you get a total of 5 square root of 10. Now there may be times when you distribute where you don't have the same numbers inside the radical. If that's the case, then you may stop at this step right here. But if you do have the same number inside, you'll need to combine them because they're like terms. Last one, 58. 5 square root of 3, 6 square root of 10, minus 6 square root of 3. Okay, so this is where you got to remember, we do combine things that are outside and things that are inside, but we don't mix them together. So 5 times 6 is 30. Square root of 3 times square root of 10 is the square root of 30. 5 times 6 is 30. Square root of 3 times square root of 3 is 3. Because remember, that's square root of 9, and square root of 9 is 3. So 30 times the square root of 30 minus 90. Now we should think and see if there's any way to simplify the square root of 30. So let's see, 2 times 15, 3 times 10, 5 times 6. And there are no perfect squares in there, so that's already as simplified as it can be. And there's our answer.